So the purpose of this video is to help us to learn to solve a system of simultaneous linear equations in a new way. Today in class, we looked a little bit at solving a system of simultaneous linear equations using the graphing method, and we'll return to that again next week to brush up our skills. There are two other methods, mainly algebraic methods. One is called the substitution method, and the other is called the elimination method, or the method of linear combination. Today, we're going to focus on the substitution method for solving a system of simultaneous linear equations. So here's the system of equations that I'd like to have us solve. 3x plus y equals 1, and negative 5x minus 2y equals negative 3. It's going to go to a new screen where those two equations are written again. Now, the substitution method is particularly valuable to us if one of the variables in either of the equations has a coefficient of 1. So if you see in one of these equations that one of the variables does in fact have a coefficient of 1. In the first equation, the variable y has a coefficient of 1. So what we're going to do in order to solve this system is we're going to isolate that variable. So in the instance of this first equation, we're going to isolate y. So y equals, and all we need to do is move the 3x to the other side of the equation. So of course when a term changes sides, it changes signs. So y equals 1 minus 3x. It's really irrelevant to this method whether we write y equals 1 minus 3x or y equals negative 3x plus 1. Either of those two would work equivalently well. So if y is equal to 1 minus 3x, what we're going to do now is go to that second equation, and where we see the variable y, we're going to replace it with the equivalent expression for y, 1 minus 3x. So let's do that. We'll begin to write the second equation over again. Negative 5x minus 2 times, here's our substitution. We're substituting in place of y the expression 1 minus 3x equals negative 3. Now why has that been a valuable step to us? If you notice the equation that's written now, we have an equation in only one variable. So we've learned a lot this year about the methods of solving a linear equation in one variable, and we're simply going to use those methods now to determine what the value of x is that will make this equation true. So let's do that, negative 5x, and I'm distributing to negative 2, so negative 2 plus 6x equals negative 3. Let's simplify the left-hand side of the equation. It becomes x minus 2 equals negative 3. And finally, solving for x by adding 2 to both sides of the equation, we get x equals negative 1. All right, so there's the value of x at which the graphs, if you will, of these two lines would intersect. That's the x-coordinate of the point where the two lines intersect. Well, what's the y-coordinate that goes along with that x value? In order to figure that out, all we need to do is now take our value of x equals negative 1, and substitute that back into any of the either of the original equations, or in fact, what I think is the easiest way to do this is to go back up and substitute it into that expression, that equation that has the y isolated. So if x is negative 1, we can substitute that in, once again, I'm just going to direct you to where I'm going to do that. I'm going to substitute negative 1 in for x. So if I do that, I would get y equals, erase the negative sign, y equals 1 minus 3 times the value of x is negative 1. So y is equal to 1 plus 3, y is equal to 4. So that is the y-coordinate of the point at which the graphs of those two lines would meet. So the solution to the system of linear equations is the coordinate pair negative 1, 4. Let's just do a quick check of that. Let's go back to the original equations, and let's make sure that negative 1 and 4 make a true statement in each of those equations. Negative 1 and 4. I'm going to take us back a page for a minute where I had the equations written, and I can work from the fresh equations there. Let me do this screen. Okay. So with negative 1 for x and 4 for y, let's just do a quick check on this first equation. 3 times negative 1 plus 4 for y. Does that equal 1? Yes, of course it does, right? Negative 3 plus 4 is equal to 1. In the second equation, negative 5 times the value of x, negative 1, minus 2 times the value of y, which is 4. Does that equal negative 3? So 5 times negative 1, negative 5. 5 times negative 1, negative 5 times negative 1 is positive 5. Sorry about that. Minus 8 is, in fact, negative 3. So we can see that the coordinate pair negative 1, 4 satisfies both of the equations and therefore is a solution to the system of simultaneous linear equations. So let's take a look at another problem here. Another system. We want to ask ourselves the question first. Is the substitution method an appropriate method to use here? The answer is yes, because as we see in one of the equations, one of the variables has a coefficient of 1. So that's the variable we want to isolate. So when we isolate x in this equation, we have x equals 4 plus 4y. Once again, it's irrelevant whether we write 4 plus 4y in that order or 4y plus 4. Now we go to the other equation, and where we see x, we're going to make this substitution. So we will write 3 times, here's our substitution, 4 plus 4y. And then I'm going to continue with the rest of the equation, plus 6y equals 3. We'll solve that equation, and we'll have the value of y here, right? Because now we have an expression that only has one variable, y. So 12 plus 12y, the distributive property of multiplication over addition, equals plus 6y equals 3. So we have 18y, and you'll follow me through if I subtract the 12 at the same time. Equals negative 9. Dividing both sides by 18, so y equals, what are you getting? Negative 9 over 18, right? Negative 1 over half. I'll get it right. Negative 1. Suddenly my smart board is not cooperating. Oh, there it is. Negative 1/2 just appeared for me. Negative 1/2. All right, so we've got the value of y. We're going to take that value of y now. Again, the smart board is not. There we go. It's responding again. I'm going to substitute back in here, and x equals 4 plus 4 times negative 1/2. So x equals 4 minus 2. X equals 2. Okay? So the coordinate pair, I'm trying to extend my page and it's not working. The coordinate pair that satisfies this system of simultaneous equations is the coordinate pair 2, 1/2. All right? I hope you can see that. There we go. All right? I'd ask you to take a look at one last system. How does this system look different from the other two we've looked at so far? Well, the equations are really not in standard form at the moment, are they? Each of the other original equations were in standard form. So what we'd like to do first is get them into standard form, collect all of the variables together so that we can see whether, in fact, the substitution method will be helpful for us. So if I add x to both sides in the first equation so that I move that minus x over to the left, I would have 3x plus y equals 2, right? And if I subtract y from both sides of the second equation, x plus y equals 2, right? Now you have a number of choices for using the substitution method in this system, don't you? Because there are variables in each of the two equations whose coefficients are 1. We have y in the first equation with a coefficient of 1, and both x and y in the second equation with coefficients of 1. So we can isolate any one of those three variables in order to use the substitution method. I'm going to leave that one for you to try on your own at this point. Okay? So I want you to solve that one and bring it into class with you, as well as 4 more equations, and I'm going to put them up on the board here now. They're out of your textbook, but I did tell you you wouldn't have to take your textbook home with you this weekend. So here are the 4 equations that I'd like you to try to solve by using the substitution method. So you'll notice if you scan them quickly that in each of the first 3, you can see, you can identify immediately that there is a variable in one of the equations whose coefficient is 1. Number 25 is similar to that last one that we looked at together, where you'll need to put that into standard form before you can be sure that there is a variable that will have a coefficient of 1. Okay? So I'm going to just let that sit there for about 15 more seconds. You can always go back on this video and pause it. So write these down so that you can do these 4 problems for homework over the weekend, as well as the one on the previous screen. All right, thanks. I hope you've learned a little bit about the substitution method.